Hello. In this recording, I am going to talk through the review that we would do for Quadratics Unit 2. And so there are going to be at least 6 sections you would want to fill in. So make 3 sections on front and 3 on back of your paper, and we're going to fill in some examples. So this is going to be an overview of the unit. This sheet of paper that you're using helps you in 2 ways. This review right now, writing it down, will help you remember what we did. And you can also use it on the test as a review sheet. So you can use it to review, kind of as a cheat sheet on the test as well. So it helps you out in 2 ways. So 3 sections on front, 3 on back. Here's the very first section. So at the top of the very first section, if you would want the title for it, it would be factoring y equals ax squared plus bx plus c. So that was the goal, was be able to factor when we had equations where the number out front was not a 1. So 7.6 was factor y equals ax squared plus bx plus c. I'm going to do this top one as an example, but actually this one I would encourage you to write down. So this first example I do, I would write this down, and then I'll have you try one as well. So you'll have 2 examples down. This first one I'll do, second one I'll have you do. So if I want to solve this by factoring, I know that this factored form, these first 2 items are going to multiply to make 3x squared. Well, the only way to get 3x squared is 3x and x. Now this needs to also make the last 2 terms multiply to be a positive 2. Because this multiplies to be a positive, it means both of these are either positive or both negative, but since the middle term is a positive, I know that these are both plus. Now I have 2 options. It's either a 1 and a 2 or a 2 and a 1. I'll show you it can't be a 2 and a 1 because 3 times 1 would make 3, 2 times x would make 2, and 3 and 2 would add up to be 5 and not 7. So it can't be a 2 and a 1, it's got to be a 1 and a 2. Let's use the table to check. 3x plus 1 plus 1, x plus 2, 3x squared, 6x, 1x, 2. 3x squared, 7x, 2. It checks out. Now I solve. The first thing could be 0, so 3x plus 1 could be 0. Since I have first thing times second thing equals 0, it means one of them has to be 0. If it was the first thing, it'd be 3x plus 1, that equals 0. Subtract 1, divide by 3, and I get negative 1/3 is my first answer. Second answer, easier to do in your head, x plus 2 equals 0. If you subtract 2, your other answer is negative 2. If you put either one of those in for x, you would get that this statement would be equal to 0. Let's check using the calculator. So 3, and then parentheses, I think it was what, negative 2, wasn't it? Yep. 3 negative 2 squared plus 7 times negative 2 plus 2 equals 0. There we go. If you try with negative 1/3, it will work as well. There's the first one. I'd like you to try the second one on your own. So pause the video now for maybe a minute and a half. Unpause it once you've had a chance to try and want to see it worked out. So pause the video now, please. Okay, first thing you would need to do is factor it. When you factor this, it's going to be 2x minus 11 and x minus 1. Has to be 2x and x because it's got to multiply to make 2x squared. It multiplies to make a positive 11, but since the middle is negative, you know both of these are negative, and it has to be a negative 11 first and a negative 1 second. You can check using the table over here that it makes everything correct. 2x squared, negative 13x's, positive 11. Solve. Add 11, divide by 2. 5.5 is one of your answers. The other answer would be if x equaled 1. So there's the first section. You better be able to solve a quadratic by factoring. 8.5 is on graphing by factoring. In order to graph equations of the form y equals x squared plus bx plus c, we did this by factoring. So the first thing I want to do is be able to find where the x-intercepts are. The x-intercepts are going to be when y is equal to 0. And how did we do that? We did that by factoring. So what 2 numbers multiply to be 8 and add up to be negative 6? If they multiply to be a positive but add up to be a negative, both of them have to be minus, and it's going to be minus 2 and minus 4. The order in which you write that is not important. Now once I have it factored, step 2 would be stating that x equals 2 and x equals 4 are your y-intercepts. So 2 and 4 are your y-intercepts. Step 1, factor. Step 2, find the x-intercepts. Once we had the x-intercepts, we could get the vertex. That's step 3. The vertex is always going to be halfway between And you should be able to see that halfway between for this is going to be 3. If you can't see it, it's the average. Add them together, divide by 2, and that makes 3. So I know the vertex's x-coordinate is going to be, when x is 3, to get the y-coordinate, I put 3 in for x in the equation. 3 squared minus 6 times 3 plus 8. That leaves 9 minus 18 is negative 9 plus 8 is negative 1. So the vertex is going to be at 3, negative 1, right there. The last point is always the y-intercept in standard form, and that's 8. If I put 0 in for x, my y-intercept will be at 8. Plot the left side. I can sketch in the left side now, and the right side is just going to be the reflection. It'll look like that, and that's how we did graphing by factoring. Zoom it right there so you can see everything. So if you need to pause the video now to get all the steps in, make sure you've got it. The title of that second section was in 8.5. It was graph by factoring. The third section that we did was graphing in standard form. And this is when we could not factor. So if I have something in standard form but I cannot factor it, the vertex's x-coordinate is always going to be at negative b over 2a. So if I wanted to graph this one, you can see I could try factoring. What numbers multiply to be 7? Well, 1 and 7, but that doesn't add up to be 6. 1 and 7 add up to be 8. So I can't factor it. Instead, I need to use the fact that the vertex's x-coordinate is always going to be at negative b over 2a. So step 1 is find the vertex's x-coordinate by using negative b over 2a. Maybe we should write that a for this one is 1, because there's a 1 out front. B is 6. C is 7. A and B are used to find the vertex. C is used to find the y-intercept. Vertex's x-coordinate is equal to negative b over 2a. You should have that written down. I would make sure you have that written on your review sheet. This case in ours, it'd be negative 6 divided by 2 times 1. That will make negative 3. So I know that the vertex's x-coordinate is at negative 3. How do I get the y-coordinate? Same as I did before. I put negative 3 into my equation for x. So I get negative 3 squared plus 6 times negative 3 plus 7. That will be 9 minus 18, which is negative 9, plus 7, negative 2. So I know that the vertex is located at negative 3, negative 2, right there. The last point is the y-intercept, which is 7. So plot of the vertex, y-intercept is at 7. So 0, 7. Sketch the right side. The left side is just a mirror image. And then you're done. And that is graphing by using negative b over 2a, which came in section 8.3. And that was if we could not factor. So if you could not factor, you had to use negative b over 2a. But it actually turns out this is always doable. This actually would have been usable even if it was factorable. But in order to derive this result right here, we needed factoring in order to get there if you go back and review section 8.3. So that was the third section, graph by factoring by using the fact that the vertex's x-coordinate is at negative b over 2a. In the fourth section, so this is where you would flip your paper over, we compared all 3 different ways there are to graph quadratics. So at the top of that section, I would make sure you've written down the equations for each form. Standard form, y equals ax squared plus bx plus c. Factored form, y equals a, and then in parentheses, x in some number, x in another number. Could be plus, could be minus, just depends. Vertex form, y equals a, parenthesis, x minus or plus some number squared, plus or minus a number outside. So vertex form is when you have a parentheses being squared. I'll do an example of each of these, and I'll have you try to write down ones for your own. So this first one is in standard form. What do I know if it's in standard form? I know that the y-intercept is negative 8. I know that it opens upward because it's a 2, and because it's bigger than 1, it's going to be steeper. So those are the pieces of information I get from standard form. What about this one? This is in factored form. The x-intercepts are at positive 3 and negative 5. It opens upward because it has a positive 1 out front. It's the same steepness, though, as our parent function of y equals x squared. The last one, this is in vertex form. I know the vertex is past 3, so right 3 and up 12. It opens downward because it's a negative, and because it's a 4, it's going to be steeper. then y equals x squared. Those are 3 examples. I'd like you to try these 3 for yourself. So pause the video now for maybe 2 minutes. Your job is to state what form each of them are in and what pieces of information you get from that form. So pause the video now, come back after you've had a chance to try. Okay, the first one is in vertex form. Its vertex is shifted right 7, up 6. It's opening upward because it's positive and steeper because it's a 2. The second form is in standard form. It's all written out. The y-intercept is at 9. It's opening upward because it's positive out front, and it's wider because the number is less than 1 and bigger than 0. The last form, the only one left, is factored form. The x-intercepts are at positive 8 and negative 3. It's opening downward because it's negative, and because it's a 5, it's going to be steeper than the parent function. And that is it for my overview. There are 2 sections left which I did not cover, and that is going to be your task. There's 2 more sections for you to fill in. 8.4 is on graphing quadratics in vertex form. 8.6 is on comparing lines, exponentials, and quadratics. I would recommend you put 2 examples down for each of the sections. You can use notes, you can use homework, you can use the quiz questions. You can go back and look at any recordings, but probably notes and homework would be good places. I think notes would be excellent, even quiz questions. So those last 2 sections are for you. You need 2 for each. So you have to find 4 examples in total in order to fill out your final review sheet. That is it. Thank you very much. Have a good one.